Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your geology teacher, Jen, and it's time for Monday Musings. The final ice age of the Paleozoic era actually started long before the end of the era. It began during the late Devonian, and whether it was one long event or several smaller events, ended in the late Permian period 105 million years later. There were several glacial and interglacial episodes recorded in Gondwanan rocks. It's one piece of evidence that Wegener provided for continental drift. And during the late Paleozoic, the continent of Gondwana hovered over the South Pole, allowing for the buildup of permanent ice. Glacial deposits from this time are found in South America, Africa, Australia, Antarctica, and Asia. Oh my gosh. Why do so many of our continents start with an A? In the northern hemisphere, which was sitting in the tropics at the time, periods of wet and dry were quite pronounced in some places, like the Paradox Basin of Utah and Colorado, where an epicontinental sea periodically got cut off from the ocean and created vast salt deposits. Major contributions to the growth of ice actually started with plants. The rapid evolution of land plants increased the atmospheric oxygen and decreased atmospheric carbon dioxide by storing it in the coal swamps of the Carboniferous period. Having a massive continent come together over a pole. Major contributions to the growth of ice actually started with plants. The rapid evolution of land plants in the Devonian period increased the atmospheric oxygen and decreased atmospheric carbon dioxide by storing it in the coal swamps of the Carboniferous period later. Having a massive continent come together over a pole was also a major contributing factor. And increased silicate weathering added to the decreasing atmospheric carbon dioxide by reacting with it to form bicarbonate ions that eventually ended up in the ocean. So, Lastly, volcanism also contributed to some minor glaciation in Russia, as some traps opened up and started releasing lots of magmas or lavas and gases. Major uplift occurred in southwestern Gondwana right around the earliest where the earliest glaciations began, suggesting that the glaciers started in alpine areas and spread from there. And of course, Milankovitch cycles also played a part. Periods of low obliquity with decreased annual insolation at the poles were associated with high moisture influx from low latitudes and glacial expansion at high latitudes, while periods of high obliquity corresponded to warmer interglacial periods. Rising oxygen levels had major effects on the evolution of plants and animals as well. The higher O2 concentrations enabled energetic metabolic processes, leading to really big arthropods like Meganoura and Arthropleura, neither of which I would have enjoyed seeing. No, thank you. However, eventually the glacial period would hit a wall. Cooler temps and high ice coverage would hamper plant growth. Rising oxygen would lead to firestorms that would burn damp plant matter. And both of these effects would return carbon dioxide to the atmosphere, reversing the ice house. Within only 4 million years, the carbon dioxide levels would rise fourfold from where they had fallen. By the late Permian, the ice age had ended and the greenhouse was in full swing again. During this time of global cooling, an end Devonian mass extinction occurred. Weathering due to the rapid expansion of terrestrial plant life increased nutrients being put into the water. Now you would think that was a good thing, and it was, if you're algae. The problem is, algal blooms have a tendency to suck up all the oxygen from the water, leaving it anoxic and unbreathable. However, some organisms like stromatoporoid sponges, and to a lesser corals, thrive in low nutrient water, which means the influx of nutrients was overwhelming for them. Stromatoporoids, when extinct, while rugose and tabula coral suffered heavy losses. As global temperatures dropped, so did ocean temps. Many of the marine ecosystems were hit hard as they were adapted from warmer waters. As ice formed on land, sea levels also dropped, exposing some of these ecosystems. Volcanism also contributed to the extinction event, changing climate on a smaller scale as Russia began to rift apart. This caused eoxinia, a combination of anoxic and sulfitic water, which is a nasty combo. All in all, 3 trilobite orders went extinct. Ostracods did not go extinct but suffered huge losses. Cystoids also went extinct, while brachiopods, ammonites, conodonts, and graptolites were also hit hard, but they didn't go extinct. Vertebrates were not hit as hard, but some did face extinction, such as most jawless fish, gone. And Lepistostigalians, such as Tiktaalik, went extinct. However, true tetrapods actually experienced irradiation after the extinction event. Well, thanks for coming to today's lesson, and make sure to tune in tomorrow for some fun trivia. Fossilise you later. Spirit supernatural, I'll shy